Hello everyone, hope you are doing fine. So this is going to be the result of this tutorial. We're going to be teaching you how you can track objects and also move towards them. And as a side bonus, we're also going to take care of how you can move the camera smoothly through an animation towards a given position, which is very useful for an RTS. So let me show you how you can do this. Alright everyone, welcome back to a new tutorial. So this was the project as I have left off with the prototype scheme so we can apply some tutorials on it. And while I'm working on some important tutorials like the interface built-in stuff, I'm going to be teaching you how to use the camera in some of new techniques here. Mostly regarding tracking cameras. So we want to track targets and we also want to move our camera to a given position very smoothly. So there are a couple ways of doing this. I'm going to be showing you the fastest and simple way to do it. So let's open the code here. And all I want to go is go to a processing function. So this camera is a little bit different than our last tutorial, but basically you can build this camera by watching the first tutorials. I have updated and refactored the code, so whenever we finish the series I'm going to be reteaching the whole series again, but this time with a enclosed project so we can have a clean code, and I'm going to put a course and stuff. So don't worry about the code itself, because this is just to control the camera. The only new thing that I think it's not have been added on the previous tutorial is these new things here, which also was not available on Godot at that time, I believe. And these are simple, some export properties. So whenever we select our camera, there's some separation here, as we can see, export category, and we have a cam target. We also have a camera speed control with some properties here and some switches. So this is how you can do this inside our camera. So I have some control over the properties from the inspector. So this is the one that you are worried about. We want to export a variable that's going to be assigned as our target node. The node that's going to be written here, that's going to be chosen here, is going to be the one we will be following. And you can also update this variable through code. But on this tutorial, I'm going to be simply following a single unit. So on our units list here, we have this one, and I think I should be showing you which stage this project is in. So if you follow the previous tutorials, I did an update and I also showed what the state this project is in. So we have the main controls for the camera, some stuff here. We also have a automatic pen based on the borders, and we can move a couple of units to randomize positions. That's about it. So I have taken a step back from the previous RTS states to a more legacy one so you can follow through the tutorials. So okay, this is the states our RTS is in. So we want to pass a unit for our camera through this variable because we have generated a new one through this code. So we want to follow a node here. So in the case of our exported variables, we have exported one as a node 3D. So this is going to already filter our nodes list. You can see we have a control, a label here that is not being shown here. That is because we have exported this variable as a node 3D. So Godot already filters all the inputs for this variable as 3D nodes only. So we're going to simply select our basic unit 1, which corresponds to this bottom unit here, which I'm going to move to the center of the scene here so we can differentiate from the other units from our project. Alright, so we have passed a target node, and now we want to code the code itself that's going to update our camera position. So now here back some questions. So the first one is how often you want to update the camera position towards your target node. This is a very important question because it also relates to performance. In our case, we have a single camera for the player, so we are not worried about performance ever. So in our case, because this entire code is running only a single instance, because we only have one camera, I can simply put the code that's going to allow our camera to follow a target here on the process function. So I just want to point out that this line of code here is just some properties here, so nothing to worry about. So okay, we want to update the camera in our process function. This means that based on the frame rate, we are going to be running this function a bunch of times. If you run this on the physics process delta, this is going to be limits to your physics tick rate. And if you have the physics process frame rate set as the default project, which I believe it's 30 FPS, you're going to have a lot of issues. As you can see here, we only run 60 frames on the physics side of things. So if you have a monitor that is higher than 60 frames per second, you're going to see some lagging behind from this function. So be wary of that. So this is common stuff from the process and physics process function. So, okay. It shows the process function to update our camera position. What is the code that actually is going to follow our camera? So I'm going to basically update the position of our camera towards our targets. So the way that my camera system works, if I open here very quickly my camera scene, is actually very simple. We have a base camera, we have a socket camera that's going to basically stick this up, and it's going to serve functions like the rotation on this angle. And the position on the Z of the camera is going to take care of the zoom. So we basically want to move the camera like this to follow anything on the map, or move on the map based on the player controls, and also rotate like this whenever we want. The camera socket is going to hold this position from the 0 coordinates, so it's going to stay above the floor and take care of the X rotation. And whenever we want to zoom the camera, this is going to be the Z coordinates on the camera itself. So that is about it. So I'm not going to save those changes. Now let me just return to my scene here. And let's just see if I did not change anything. So, all right. So that is how my camera system works. And I think that the way we're going to do this is simply allowing our camera base, which controls our entire camera system, X and Z position, to follow our units. So if you see here on the Godot gizmo, the up coordinates is Y, so you only want the Z and X position to follow our units. You can also do the Z, but in our case, we don't need it. So the code for that inside our project to follow a unit is going to be very simple. We're going to be putting this code inside of our camera. So if you see my camera scene here, this is the camera RTS base script. So this is the code for the base of the camera. So all I'm going to do is say that our global transform, which corresponds to our transform inside the 3D world, our global, we want its origin, basically its position center, X, to be equal to our global transform, but this time we want to grab it from our target nodes. So let me just see how I've typed here, which is target node. And we want its global transform. So I have swapped this up. So we want to grab from our target node its global transform, its position, so its origin X. This code alone is going to take care of that. So let me duplicate that and do that for the Z-axis. You can also do this without it, so like this, and it's going to work just fine. So the position is going to be basically be transferred from the camera, which is running this code, to our target node global position. And this is basically doing the same thing, but here we are discarding the Y coordinates, so we're only using the X and Z, which corresponds to the top-down positions. So if we run our project, this should take care of our position. So now we are stuck with following our camera units, which is this single guy here. And as you can see, we are already following our units. Now, there are some issues here, mainly regarding the offset, but there's also some things we can change. But as you can see, this simple line of code has made it up so our camera now follows a given target unit. So this is basically the main idea of this tutorial. You can now follow the units, and every single process is going to try to teleport it and update its position to our units. Depending on how you are updating the unit's position, you're going to notice some jerking around, but that is accounted for with the code. So that is about it. Now, if you want the position to be stuck to the unit and do not follow any single type of movement, you basically can paste this above all the camera functions. So after all of our camera has done its thing, so let me just do that, you can basically say it to follow it around. So now any extra movement is going to be basically ignored. As you can see, the pen does not work and any commands that I give are not being followed. The position is just being updated and overriding any other code we give to the camera. So that is how you can basically override any camera control, by just placing this code on the bottom there. I, however, are going to let it on the top here, because I also want the player to keep control of the camera while we are still tracking some target nodes. So that's basically it. However, there's some issues here, mainly to point that our camera is basically stuck in our character and there's no smooth movements whatsoever. So it's basically stuck in there. So I want to make some kind of interpolation between our current position to our target position. And the main function that takes care of that is lerp. So lerp is basically a interpolation function which interpolates it linearly. So you can implement any kind of algorithm you want to interpolate these values. Just keep in mind that lerp is a linear interpolation. So if you want some kind of smooth interpolation like Bezier curve style, you're going to have to do that on your own with a custom algorithm. Godot has a cubic interpolation, I believe. So you can also do that. There's as you can see here, a cubic interpolation for vector free. And there's a bunch of stuff you can also use. So there we go. This is the code for cubic interpolation. So yeah, I'm going to be basically using lerp for this. So lerp, there's a problem here because lerp is basically lerping from variance. So the way I'm going to do this is use the x and z with different interpolation values. And also keep in mind that lerp does not actually change the value we are lerping. It just returns a variance from the given and the target's variance. So we have to basically assign it. So let's just mute the code from the top here and let's do x is going to be equal to a lerp, and the lerp is going to be between our x position, global transformer, towards our target position x, and I'm going to be basically copying this. And there we go. I'm going to do a split here so you can see the code, and let's see what is wrong here. So there's too few arguments, so there's also other stuff we have to type, and it's the weight. So here is by how much you want to lerp. So it's basically a smoothing. Think of this as a smooth factor. So we want to give a very smooth operation. So let's put 0.5. And now basically let's copy this to also interpolate on the z-axis. So let's basically switch all the axes for z. And that should take care of our interpolation. And whenever we run our project now, you're going to see that the camera is going to stick around for our guy, but now it's going to interpolate a bit. So whenever we move our guy, you're going to see that the camera now smoothly follows it. And the amount of smoothing we are going to be doing is basically this value, which we can simply say that it's going to be a constant. That's going to be a smooth factor. Let's put just weight. So I weight. And this is going to be a float, and let's give an even smoother value, so something a little bit lower, and just let's put it like this. And whenever we run the scene, it's going to apply that. So it's going to be very smooth, and actually it's too much. So let's do a little more. And as you can see, it's still very few. So let's increase it. And there we go. And now it's too much. I think this one is going to be all right. So yeah. So as you can see, this is basically linear interpolating these two values to match the units of the position. So yeah, the camera is basically following the units now through a linear motion. So it's not anything fancy, but it takes the job well done whenever the unit moves. So this is the movement from the player camera controls. As you can see, very simple, and now it smoothly follows our target unit, which is pretty cool. Now you're wondering why we're not actually looking at the unit. So our camera base is following the unit, but our camera is looking at whatever we want. And the player can look at whatever, and the camera base is being following the units, but it's not looking at it. So this is another issue. So there's a simple function in Godot, and I think in most engines, that makes one 3D object looks towards another, and that is inside of Godot represented as look at. So you have to search for this function from your engine, but this basically is going to ask for two vectors, and it's going to make the first one looks towards the second one. However, this function does not return anything, so it actually makes the property you assign to actually look towards the given target. So now that we have done this, let's take care of our camera. So this var here is being assigned as our, let me see if I can find it. So here is it. So this is basically on the structure of our camera units here. This camera var is actually assigned the camera object itself. So the camera, we are only take care for the zoom. So it wants the camera object now to look towards our units. So we are going to access the camera and say that it's going to look at our given target. So this is going to be our target node. However, we need to input here that it is actually its position. So you can use global transform origin, or you can use a shortcut that Godot has, which is global position, which is basically the same thing. You access it, yeah, here it is. It's the same as using global transform origin. So if you do that, now look at what we have. Whenever we run our project, you're going to see that camera is going to stick towards our units and is going to look at it. So I don't know if you noticed some games that use this type of camera, and mostly like, let's say on the first person shooter, whenever you die, you're going to see that they use this type of camera. Now the zoom function is going to work as it should. However, any kind of rotation, it's going to try to fight with the camera code. So yeah, it's going to jerk around because the player wants to move the camera towards one rotation code, and the code we have placed is going to try to look towards our given target. So of course there's going to be some jerking around. So depending on the code that you're applying this, you're going to see that there is some jerking around. You're going to need to update the code. Or you can simply paste this code here after you have applied everything. So it's going to overwrite every single code you're going to type. So as you can see now, the code is a little bit smoother, the operations, but it's going to give a little bit less control. So it's not that reactive towards the player. But as you can see, this is the final results. We now are looking towards a given unit, and we are also tracking its position with our camera base to allow it to follow. And as you can see, the camera base panning is trying to move the camera towards the given position, but is also teleporting it back and also try to look towards it. And you can also mix and match these without having any issues. So let's say we don't want to follow the units, but you still want to keep looking at it, like some kind of cinematic or stuff. If you do that, it's going to apply that to the code, but the camera position itself is going to remain put. And as you can see, this is the effect you give. Now, of course, because of the orientation of the commands and the camera looking position is going to be weird, because if I press W, you're going to see the camera moves towards that position. So I'm pressing W and S and not A and D. So you have to update the code of your camera if you want to move the camera according to the target position. So this stuff should be a little more advanced because you're going to have to take care the account of the unit position to accord the updates. So you have to update the inputs towards the given units. So yeah, you have to change your code a bit if you want to do that kind of stuff. But as you can see, we are basically tracking the camera orientation towards the units, but the camera base is being put. So as you can see, that is the effect it gives, which is pretty cool. So there we go. Now for the last bit of this tutorial, I'm going to teach you how we can basically move the camera smoothly towards a given position. So this is basically the code that's going to track our targets. So track targets. And now let's make a code that's going to basically move our camera very smoothly towards a given position. So the way we are going to do this, and you can also do global transform equals to a given position, is going to basically teleport the camera towards a given one. But I want to do it a little bit different. So I want to use something called twin inside of Godot. And I don't know if you know about this. It is now a class. It was previously a node. Now it's just an object. You don't actually add it as a node, I think. Twin is not available as a node. So it's basically a object you create and it auto deletes itself. So you don't have to store it. We're going to use this to create an animation for our position, and it's very simple to do so. And I'm going to actually do this on our ready function. So after we have been generated our ready function, I'm going to basically twin this to our target position. So the way you do this is by accessing first our tree, because we want to add that twin node. We want to create a twin. Now let's access its properties. So I'm going to do this, which is basically still part of the code on the top here. And the way you can do that is by simply placing a I forgot what the IP reference is, and this is going to be basically allow you to keep code this way. So we can do that, and here we're going to set some properties for our twin. We basically now want to define what type of property we want to twin. In this case, we want to twin our self position, and we want to twin this towards our position. So this is the way we do it. We first access which object we are accessing the property, and it is ourselves. Next, which one we are doing. So this is going to be our global position. I'm going to change this a bit, and I want to change its X position. So I think I'm gonna actually do this entirely as it is to not duplicate the twin. So let's do it like this. Next, which is the target position we want? It's our target node with its global position. Next is going to ask for a given duration. So let's put this down here so you can see. I can actually do this. So let's do like that. And the duration we want is the animation duration for this twin. And let's do very smoothly. So let's put 2 seconds. And let's also add some new properties here. We want to set its ease. So ease when twin is basically what type of animation you want. So the easing for the animation. So you can search this online about twins. I'm going to basically use here. And you can understand because we are going to apply a property here that is ease in and out. So if we search for this, there's a combination here. So the templation starts slowly or starts quickly and slows down. So this is basically what it means. And we also want to set another thing here for our twin, which is its trans. So trans is our, forgot what it's called. It's for transition. There we go. So our twin is going to transit from the start and the end value based on the transition type. And we have a couple of types here. We have the linear, we have a sine, quinter, and you can see online for a graphical representation from these transitions if you want. But we basically want to use one that is very smoothly, and this is going to be our transition sine wave. So this is the guy. So there we go. Now this code is going to align our camera towards that given position. So it's going to create a twin that's going to twin our global position towards our target global position. After 2 seconds, it's going to reach that target. So the animation is going to have 2 seconds of duration. Set its twin to be ease in and out, and we set its transition to be a sine wave. So now if I place the camera on our 3D scene, or actually not the camera, but our units. So if I grab my unit here and let's place it somewhere else, so like something like this, and I run my scene, you're going to see that the camera now is going to smoothly transit towards that given unit. And there we go. So if we want it, you can also keep the code that also is going to look at. So we can do this here. So it's going to teleport the camera and is also going to look at it. So there we go. And this is how basically you can do these types of animation. So where this is useful, let's say you want, whenever the RTS game is running, you want to teleport the camera position towards someplace else, you can use this bit of code to do that. And if you want to track a target, you can use this bit of code, which basically is going to move the camera towards the given target. And these two codes can also work with each other because they are being added through the code. So there we go. On this tutorial, you'll learn a bunch of cool tricks that's going to allow you to move your camera. There's also, as a side note, whenever you do a twin with your camera, you want to basically disable your camera from processing so the player doesn't move it. So you can add some switches like this one, which is simply a Boolean value that's going to basically turn on and off your camera control for the player. So whenever you move the camera towards that position, you don't allow the player to move the camera whatsoever. So there you go. That is basically it. It's very simple, and that is how you can teleport your camera towards a given position. So very simple stuff. Hopefully you have enjoyed this tutorial. And yeah, that is basically it. You can use now these mechanics that I have teach to make a camera system of your choosing. and also to update with some code that's going to take care of some offsets. So this is the main idea, but you can also update it with your ideas as well. So yeah, that's about it. So thank you guys for watching, and hopefully you like this one, and I'll see you on the next one.